This video is about practice for mathematical induction. A. Let f of x equals square root 1 plus x for x greater than -1. Show that f double prime of x equals -1 over 4 square root 1 plus x to the third power. For f of x, we need to change it into exponential form, 1 plus x to the 1/2 power. F prime of x, using power rule, 1/2, 1 plus x to the 1/2 minus 1 is -1/2 power. F double prime of x equals, power rule again, 1/2 times -1/2, 1 plus x to the -1/2 minus 1 equals -3/2. By chain rule, x prime equals 1 equals -1 over 4, 1 over square root 1 plus x to the third power, which is -1 over 4 square root 1 plus x to the third power. Let's go to B. Use mathematical induction to prove that. We will use a CAP method. Check, assume, proof. Check the statement is true for n equals 2. Since the statement is complicated, we will get started from left-hand side. Equals f double prime of x. We already figured it out in part A, -1, 4 square root 1 plus x to the third power. Right hand side equals, when n equals 2, we have -1 over 4. 2 minus 1th power is 1 times 2 times 2 is 4 minus 3 factorial, denominator 0 factorial, times 1 plus x to the 1/2 minus 2, organize -1 over 4. This is 1 over 1. 0 factorial equals 1. 1 plus x to the -3 over 2nd power. Organize -1 over 4 square root 1 plus x to the third power. Since left-hand side equals right-hand side, it's true for n equals 2. Second step, assume the statement is true for n equals k. We will change every single n into k to get this statement. Last step, prove the statement is true for n equals k plus 1. We will change every single k into k plus 1. -1 over 4. K plus 1 minus 1 will be k times 2 times k plus 1 minus 3 factorial over k plus 1 minus 2 factorial times 1 plus x 1/2 minus k plus 1. When you change k into k plus 1, remember, put the parentheses, organize -1 over 4 k times 2k plus 2 minus 3 is 2k minus 1 factorial. K minus 1 factorial as a denominator. then times 1 plus x. 1/2 for minus k minus 1 will be negative 1/2 minus k. We will prove this statement is true. Left hand side equals f k plus 1, the derivative of x, equals. We will connect this with kth derivative of f of x. F kth derivative of x prime. We do substitution. Substitute this for f kth derivative of x. That is negative 1 over 4 k minus 1th power times 2k minus 3 factorial k minus 2 factorial times 1 plus x to the 1/2 minus kth power prime. This is a coefficient we bring down. Then times power rule 1/2 minus k times 1 plus x to the 1/2 minus k minus 1th power. Organize negative 1 over 4 to the k minus 1th power times 2k minus 3 factorial k minus 2 factorial. We put this together, k over 1 times, denominator is 2, 1 minus 2k times 1 plus x to the negative 1/2 minus kth power. Remember, our goal is this. It's so hard to change 2k minus 3 factorial into 2k minus 1 factorial. So we will work on right hand side. Let's get started from right hand side equals negative 1 over 4 kth power times 2k minus 1 factorial. I can change into 2k minus 3 factorial times 2k minus 2 times 2k minus 1. For k minus 1 factorial, I can change into k minus 2 factorial times k minus 1. Then times 1 plus x to the negative 1/2 minus kth power. We get these two are equal to each other. We need to change this into this equals negative 1 over 4. I will use this k minus 1th power, k minus 1. Then I add 1 times 2k minus 3 factorial. Factor 2k minus 2 is 2 times k minus 1. Then 2k minus 1. Denominator k minus 2 factorial times k minus 1 times 1 plus x to the negative 1/2 minus kth power. That equals negative 1 over 4 k minus 1th power times negative 1 over 4. Reduce times 2k minus 3 factorial times 2 times 2k minus 1 over k minus 2 factorial times 1 plus x to the negative 1/2 or minus kth power. Simplify, reduce. Negative 1, we do distributive property here. We will get negative 1 over 4 k minus 1th power times 2k minus 3 factorial over k minus 2 factorial times 1 minus 2k over 2 times 1 plus x to the negative 1/2 or minus kth power. You could say right-hand side and left-hand side, we get exactly the same algebraic expressions, which means it's true for n equals k plus 1. We finish proving. Let's go to C. Let g of x equals e to the mx power. M is rational numbers. Consider the function h defined by h of x equals f of x times g of x for x greater than negative 1. It's given that the x squared term in Maclaurin series for h of x has a coefficient of 7 over 4. Find the possible values of m. Let's go to Maclaurin series. The coefficient of x squared is h double prime of 0 over 2 factorial equals 7 over 4. We need to figure out h double prime of 0. For h prime of x, use the product rule. We get f prime of x times g of x plus f of x times g prime of x. H double prime of x equals, do the product rule again, f double prime of x times g of x plus f prime of x times g prime of x plus product rule again, f prime of x g prime of x plus f of x g double prime of x. Combine like terms, f double prime of x g of x plus 2 times f prime of x times g prime of x plus f of x times g double prime of x. We know f of x equals square root 1 plus x. F prime of x equals 1/2. 1 plus x to the negative 1/2 power, which is 1/2. 1 over square root 1 plus x. F double prime of x equals negative 1 over 4 square root 1 plus x to the third power. For g of x equals e to the m of x power, g prime of x equals e to the mx power times m. G double prime of x equals e to the mx power times m squared. Then we can figure out f of 0 equals square root of 1 equals 1. F prime of 0 equals 1 over 2 times 1 over 1. 1/2 f double prime of 0 equals -1/4. For g of 0 equals 1, g prime of 0 equals m, g double prime of 0 equals m squared. Therefore, h double prime of 0 equals f double prime of 0, g of 0, plus 2f prime of 0, g prime of 0, plus f of 0 times g double prime of 0. Let's do the substitution. -1/4 times 1 plus 2 times 1/2 times m plus m squared. Let's organize. -1/4 plus m squared. Since h double prime of 0 over 2 equals 7/4 times 2 both sides, h double prime of 0 equals 7/2. -1/4 plus m squared equals 7/2 times 4 both sides. -1 plus 4m plus 4m squared equals 14. Since this is a quadratic equation, we try to make the equation equal to 0. -14 both sides, 4m squared plus 4m minus 15 equals 0. Ninja X, 4 times -15, -60, +4 over 4/4, -60, +10, -6, 10, -6, reduce, -3/2, 5/2. Variable is m. Then bottom up, 2m plus 5 times 2m minus 3 equals 0. m1 equals -5/2. m2 equals 3/2. We have two solutions for m.